everyone, and welcome to topic 10. In this topic or this chapter, we are going to be discussing a different kind of movement that can happen on a graph. In topic 9, we were talking about rigid motions, so motions that moved a figure on a plane or on a coordinate plane, but did not change the shape of the object being moved. Today and throughout this chapter, we're going to be talking about what happens when we move a figure on a coordinate plane and it changes size and shape. So that's what we're talking about today. And this video is about 2 minutes long. We're going to watch this together. And the key term you need to remember is that with topic 9, everything we talked about was when a movement happened, it was congruent. In chapter 10, when we are talking about the movements that are happening here, we're going to be using the word similar. And when we talk about similar triangles or similar polygons, we are talking about polygons that have the same angles but different side lengths. So we're going to go ahead and talk about what that means and watch this video together.
A dilation is a transformation that moves each point along the ray through the point starting from a fixed center. And multiplies distances from the center by a common scale factor. Notice that the distance from the origin to the point A prime is twice the distance from the origin to point A. Also, the distance from the origin to point B prime is twice the distance from the origin to point B. And similarly, the distance from the origin to point C prime is twice the distance from the origin to point C. If a vertex of a figure is the center of dilation, then the vertex and its image after the dilation are the same point. Point D is the same as point D prime. The scale factor is the ratio of a length in the image to the corresponding length in the original figure. The length of side A prime, B prime is 6 units. The length of side AB is 3 units. 6 divided by 3 equals 2. The scale factor of this dilation of rectangle ABCD to its image A prime, B prime, C prime, D prime is 2.
All right, we're going to pause that song this time. Okay, that was a lot of information. So I'm going to back it up and we're going to go through it together without them talking through it. So that way I can explain it a little bit better, hopefully. So here is a shape that we have on our coordinate plane. This one happens to be a triangle. So we're talking today about dilations. So a dilation is when the shape grows or shrinks on your coordinate plane. So it's either going to expand or contract. All right, and just like with rotations, it's doing that based off of a specific point in the coordinate plane, and almost always that point is the origin, 0, 0. I don't know of a situation where it's not common to use the origin. So most of the time it's the origin, but the problem will always tell you to dilate it from the origin or from a specific point on the actual shape. Okay, so it just means that it is growing or shrinking. So when you're working with dilations, you're going to be working with something called a scale factor. So a scale factor tells you how much to grow the shape or shrink the shape. So if it is a scale factor of 2, you're going to double the size of the shape. If it's a scale factor of 1/2, you're going to shrink the size of the shape. It's going to result in a smaller shape, half the size of the original triangle. Okay, so let's go ahead and watch this part here. So this is going to be the fixed location that the shape is going to dilate from. It's going to grow. And it kind of draws these lines to show you that it's as the triangle expands, it's going to follow these lines. So you can picture this if you use any sort of touchscreen phone and you zoom in on something, your fingers are sliding open the image. That's kind of what it's doing here. You're sliding it wider or you're sliding it narrower along based off of a fixed point. All right, so let's go ahead and look here. So they show that you've now doubled the size of triangle ABC. And you know that you can double this by looking at the coordinates. So take a look here. We're jumping a little bit ahead in this lesson, but that's okay. Coordinate A is at 1, 2. Well, if I double that coordinate, it's going to be at 2, 4. So look at this. 2, 4 is my new triangle. Okay, and it's not always going to be double. Sometimes it'll be triple, sometimes it'll be 2.5, or sometimes it'll, like I said earlier, it could even be shrinking. But you can always take the coordinates and multiply them by whatever your scale factor is to get your new location of your triangle. All right, and what's cool about this is the side lengths. If this situation, they're doubling this dilation. This is a doubling or a 2 times scale factor. That means that each one of these side lengths, this original side length is 2, or this blue side length now is 2 times as long as the original side length. And this BC side length is 2 times as long as this BC side length. But what's cool about dilations is that the angle measurements inside the shape stay the same. So I don't know exactly what these angle measurements are, but let's say this was 60 degrees. If angle BAC is 60 degrees, then this angle right here is also 60 degrees. That's part of the rules of dilations. The angles stay the same, the side lengths change. And it's also showing you that the distance from the origin doubles. And now we're switching to an example about a rectangle. So here's our rectangle. And sometimes the rectangle or the shape that we're working with is going to have a point on the origin, and that's totally fine. It still works the same way because this coordinate right here, remember I told you can multiply them, is 0, 0. Well, what's 0, 0 times 2? It's still 0, 0. So if we're doubling this, the origin is still, that coordinate is still going to stay on the origin. Okay, and then it's reminding us, or teaching you, I guess, not reminding you, that we can calculate the scale factor by saying, okay, here's the length of this one leg, and here's the length of the corresponding leg. That just means the same leg in a different picture or a different shape. And we can say, well, what's the new leg divided by the original leg? So this was 1, 2, 3, 4, 5, 6 units long, and this one is 1, 2, 3 units long. So 6 divided by 3 is 2. And it's important that you do it from the new figure to the old figure, so that way you get the correct ratio. If you accidentally did this the other way, if you did 3 divided by 6, you would have gotten 1/2. And that would mean that this blue rectangle should have been half of this original rectangle. And that's not what we have here. We have it doubled the original rectangle. Okay, so just make sure you put those in the correct order. And I know we're going quickly through this, but we will go through more examples together. We're skipping that video and it is time for part 1. Okay, so which one of these is a dilation? Can you tell? Hopefully this one stood out to you as being a dilation, and you might have said, well, this one could have been too because it shrunk. But if you take a look, the side lengths are not the same. This is not the same shape. It doesn't have the same characteristics as the first triangle. This blue triangle has a really short left leg, a really long bottom leg, and then a really elongated hypotenuse. This one has the ratio of almost like 2 to 3 in the side lengths here, and it doesn't follow that same shape over here in this triangle. So we know that this is not a dilation. It's actually not even any type of transformation. And then this one, it just looks like they slid this triangle up to the right. So that is a translation, not any sort of dilation, which leaves just that middle option. So now in your book, see if you can figure out which one of these is a dilation. Hopefully you were able to quickly say, oh, that's going to be option 3. And this is an example of when the triangle was dilated based off of a point inside of the triangle. So they just used this point B as the same point, and then they grew the triangle this way. All right, this is actually called an inscribed triangle, and you'll learn that later on in high school. All right, so like I told you earlier, there's 2 ways we can dilate a shape. We can either grow it or shrink it. And the mathematical term for growing it is an enlargement, and the mathematical term for shrinking it is a reduction. So an enlargement is when you have a scale factor that's greater than 1. So let's watch this example.
Suppose you have rectangle ABCD. You want to enlarge it using scale factor 3 with center of dilation at the origin. A is 2 units from the center, so A prime is 3 times 2, or 6 units from the center. C is 3 units from the center, so C prime is 3 times 3, or 9 units from the center.
Multiply by
Similarly,
3.
B prime is 3 times as far from the origin as B. D is at the center, so D prime is in the same spot. Rectangle A prime, B prime, C prime, D prime is an enlargement of rectangle ABCD.
All right, so again, they did it based off of side lengths. You could have done it based off of coordinates too. That would have worked. This looks like coordinate 0, 2. So if you multiply 0 by 3, you still get 0, and 2 by 3, you get 6. So you can move that, find that new coordinate. Let's go ahead and watch this one about how to make a smaller one.
Suppose you have rectangle ABCD. You want to reduce it using scale factor of 1/3 with center of dilation at the origin. A is 6 units from the center, so A prime is 6 times 1/3, or 2 units from the center. C is 9 units from the center, so C prime is 9 times 1/3, or 3 units from the center.
Okay, I fast forwarded this part a little bit for the sake of time, but basically, as you can see, they took all of the coordinates and they multiplied them by 1/3, and they got this smaller rectangle, so it was a reduction. I'm not sure we'll be able to get this whole video done in the next 2 minutes, but if we can, great. If not, go ahead and find that second video for this lesson. But let's do our best to get through it. So we have our first problem where it's asking us to find the scale factor. So the scale factor, we do the new divided by the old, or the original. So the new one, let's look at line PS. The new one is 1, 2, 3, 4, 5, 6 units. So that's 6 units. Divided by the old, we have to look at PS again. 1, 2, 3. 6 divided by 3 is 2. I would say 2 is probably the most common scale factor you're going to see when working with the with scale factors. So now you can try this one. Remember, you have to do the new, the blue, divided by the old, the black, and see what you get. Line LM, if we use that, is 1, 2, 3, 4. This LM is 1, 2, 3, 4, 5, 6, 7, 8. So 4 divided by 8 would be 1/2. So the scale factor is 1/2, and it's a reduction. All right, friends, we do need that second video. So I'm going to pause this video here. Go ahead and find the second video. We'll finish up part 3, our close and check, and then we'll be done with this lesson.